Okay, this is section 3.3. We're going to talk about circular functions. We need to refer back to our x's, y's, and r's before. So technically we always said x over r and y over r is your sine and your cosine. I guess in the other order, but and then tangent is your y over your x, and then you flip them, right? Well, in the unit circle, we are going to say that your r is equal to 1. So you essentially, when I say your cosine is your x, your sine is your y, tangent is y over x, that part isn't necessarily changing. The reason I want you to think about it that way is we need to refer back and think in those terms, except now I'm going to give you radian measures and we're going to solve triangles. Okay? So we're kind of going to throw everything back together here. So if I give you that I want to solve the trig functions, all the possible scenarios for 5 pi over 6, what we need to figure out is where is 5 pi over 6? If you think about 5 pi over 6 and you're like, I have no idea, then you need to convert it. Times 180 over pi. The pi's cross. 6 goes into 180 30 times. 5 times 30 is 150. All that's saying is, can you solve a triangle for a 150 degree angle? Okay, so 150 puts you in the second quadrant. What you need to find is your reference angle. What is that angle inside in here? My theta hat. My theta hat ends up being a 30 degree angle. Or some of you might be able to look at that radian measure and say, hey, half a circle is pi and I'm pi over 6 short. So you might be able to instantly look at it and know it's pi over 6 and make the connection for 30 degrees. So I don't really care how you go about doing it, as long as you can find 30 degrees. And as long as you can say, okay, if 30 is there, that means the 1's there. The square root of 3 is on the bottom. 2 is the radius. And it's going to be negative to the left, but positive going up. And now you find your relationships. The sine is your y over your r. The y value in this case is a 1. R is 2. So sine is 1/2. Cosine, negative root 3, is the x over 2. And then the tangent is going to end up being negative 1 over root 3. I hope you're all okay with me just doing the negative root 3 over 3 at this point. And then how do you find the other 3? You just flip them. So if I know sine, cosecant is going to be 2 over 1, or just 2. And then the secant is going to be negative 2 over root 3, but remember you need to do the root 3 over root 3 idea. So it's negative 2 root 3 over 3 as the actual secant. And then cotangent is actually just going to be your x over your y, which is just negative square root of 3. Alright, so that is how you go about doing the triangle. This last part shouldn't have been anything new. This should actually be relatively easy once you figure out how to set up your triangle. So in this case, I'm just giving you a radian measure. You need to find the reference angle because that's your key to figure out if it's 30, 60, 90 or 45, 45, 90. And then the rest is as normal. Okay, now we're going to do something a little bit different. I'm going to use the unit circle. And I want to find all values that make this situation true. Now t is just an angle, it's theta, they just give it a different letter, okay? But I want to be between 0 and 2 pi. If I ever give you or the book gives you these bounds, that means that all of your answers need to be in radians. Okay, so you're going to either use the degrees and convert them to radians or just straight out find the radian measure. Now, in order to do this, I need a reference angle. I need to figure this out. At least I know cosine's positive. Cosine of this angle gives me a positive 1/2. If you think about your all students take calc, or cosine is your x, where is cosine positive? You should make the connection that I need an answer in quadrant 1, and I need an answer in quadrant 4. Okay? Because of cosine being positive. How do I find my reference angle? The only way to do this is one of two options. You could take the cosine inverse and actually get an answer in degrees. Okay? So you could do t equals cosine inverse of 1/2. Alright? Now, I want to steer you away from that because what happens if I take your calculator away? Alright? So what I want you to do is think about cosine's relationship is x over r. I have a triangle in the first quadrant. My x value says it's 1. My radius says it's 2. Okay? Do you recognize a special triangle there? 1, 2, square root of 3. Which leads me to believe that my reference angle has to be a 60-degree angle. Okay, so that's how you can go about kind of deciding what your reference angle is going to be. Actually start building your triangle, because you know the relationship of x and r. You can figure out that the y is root 3. The only thing that's different about your reference angle is still 60 down here. It's still 1 to the right. You're just going to be negative root 3 down. So that's the only thing that's changing. Your radius is 2. Alright? And they say, alright, we need to find our actual angles. Okay, so for the first quadrant, okay, it's straightforward. 60 degrees, but I want it in radians. So the correct answer would actually be pi over 180 is going to be pi over 3 is your angle in the first quadrant. Okay? Problem is, in the fourth quadrant, I'm 60 degrees short of 360. So that'd be like a 300-degree angle. Another way to think about it is I'm pi over 3 short. However you think about it, okay, 300 would end up being 5 pi over 3. Or you can think about it as I'm pi over 3 short. So these would be my two angles that make this scenario true between 0 and 2 pi, or 1 full rotation through your circle. Every time cosine, sine, tangent, you're going to get two answers that make this happen, because there are two quadrants in which cosine are positive. There's two quadrants in which sine are positive, or cosine, or anything like that. So that would be an example of solving for an angle given a relationship of your sides. Okay, and you can actually set up the special triangle and do that. Just be careful that the 0 to 2 pi, you actually give your answer in radians, or unfortunately it will be considered wrong. Okay, the last thing we need to talk about are even and odd functions. Now these are actually on your salmon sheet. If you grab your salmon sheet, the middle column, it'll say even/odd formulas. That's what you need to find. Okay, now even formulas, what they are in general is, if you put a negative in, okay, it's going to be no different than if you actually put the positive of it in. Okay, so in a simple example of an even function is y equals x squared. So something along the lines of a quadratic function. Okay, if you put like a positive 2 in to a quadratic, you end up getting a positive 4 out. 2 to the right, 4 up, right? So an classic even function is if you put a negative 2 in, it should be the exact same as putting the positive 2. Well, if you put a negative 2, what's negative 2 squared? The result out is still a positive 4. That's the classic example of an even function. It's essentially symmetric over the y-axis. Okay? One of these trig functions are even. Okay? And we need to kind of talk about which one is even and which one's odd. Alright? Whereas an odd function would be if you put in a negative, okay, if you do the positive one, it's going to kind of flip it. Okay, it's going to be exact opposite. An example of an odd function would be a cubic. Okay, the reason for that is this. If you look at a cubic graph, it looks sort of something like that. And if you put in, let's say, x equals 2 to a cubic, you would have the coordinate point 2, comma 8. The problem is, if you put in a negative 2, negative 2 cubed would give you a negative 8. Alright, what they're trying to say here is, if you put in a negative 2, it would be the same as putting in a positive 2 if you change the sign of your answer. Notice if you put in a positive 2 and changed your sign, you would get a negative 8. That's the same idea. Alright? And this is symmetric over the origin is kind of the relationship there. Alright? So what I want us to do is determine if the function is even or odd or neither. If you look at this example, all they want you to do, here's f of x. They want you to plug in f of just the opposite sign. Now this is broad terms, broad terminology. This would be like negative 1 times negative x cubed plus a negative x. Okay? Do you end up getting the exact same thing or not? Okay? So negative, that would be negative x cubed would be a negative x times negative 1 would be x cubed minus x. Notice all your signs change. Okay, so it's not the same thing. So this is not even at all. Okay, and odd just means you would take your answer and change the sign. Did I change the sign? Yes, so this would actually be a definition of an odd function. But we don't need to necessarily get into the nit and grit of that. The reason is I have an actual thing for you. If you look at the even odd functions, I want you to find cosine. Okay? It says cosine of a negative angle. So the negative angle this time is pi over 6 or 30 degrees. Okay? So the negative angle one is equal to just cosine. So this is an even function. Cosine's even. If I give you negative, what's cosine of negative pi over 6? It'd be the exact same thing as saying cosine of pi over 6. Okay? Why are we able to do that? Because where's cosine positive? In the first and the fourth. If you say negative, now I know you guys are going to be easier off with the 30 degrees. Cosine of a 30 degree angle is like saying 1 over 2. Cosine of negative 30 is the still same relationship as 1 over 2. So it's going to be the same idea no matter what. Okay, so that's just the way it works, how this works. Actually, this should be your square root of 3. I apologize, and that's a 1 and a negative 1 when I say 30 there. So this would be like saying positive square root 3 over 2, positive square root 3 over 2. In either case, so it's not going to matter. Whereas sine is actually an odd function. If you look at sine negative theta, it's equal to the negative, or change the sign, of the positive angle. Okay? So you're going to be able to use those relationships every single time it's on the salmon sheet. Just don't freak out if you see a negative angle. You're able to use these opposite things. So why are these deemed as odd functions? Because if you actually set up the same type of picture, actually, I don't even need to do it again. If you actually look at the same picture, notice what's different. Okay? Sine of the positive pi over 6 answer would be 1/2, whereas sine of the negative is negative 1/2. In order for these to be equal, you need to change the sign or throw this negative sign in front. Okay? So that's why that's deemed as the odd. Now, what are you actually going to see on the problem or test or quiz and to do these? If I give you sine of negative 60 degrees, you can use these odd, even relationships, and let's look at our salmon sheet. Sine of a negative angle would be the same thing as saying negative sine of the same positive angle. This just allows us to be able to graph our equation into a quadrant that we're used to. So the 60 degree angle, 30, so I know that I have pi over 3, 2, 1. You basically get rid of the whole idea of forgetting negatives. You just got to know that, okay, the actual sine of 60 degree part is going to be root 3 over 2. Right? I just need to change the sign. So it's going to be negative square root of 3 over 2. Now this is just a property that you can use. Can you still graph negative 60 degrees? Absolutely. That just means 60 degrees down. You would just change your root 3 to negative, and you could do it via the picture as well, but this is just a property that you can use. Whereas cosine of negative 225 degrees, if you see cosine negative theta, okay, that's the same thing as saying cosine of that same theta. So what is the cosine of a positive 225? 225 puts us 90, 180, 45 degrees past 180. So that's the whole 1 square root of 2, negative, negative, and cosine is going to be negative 1 over root 2, or negative root 2 over 2. So all that does is allows us to go in the positive direction instead of having you need to go in the negative direction back and try to figure out what that angle is and so on. It just allows us to use angles that we're comfortable with. I'm sure you guys are all cringing about seeing this, but there are also some proofs that you have in your book, but they're relatively simple and they all involve the whole negative angle thing. And what you need to make note of is this. Cosine negative theta. What is that equal to on your salmon sheet? Okay? Cosine of negative theta is just going to be what? Positive, right? So it's just going to be cosine of a positive theta. So if you plug that in, hey, what's cosine theta? Tangent theta. Well, tangent theta we should know now as y over x, or the sine theta over cosine theta. Cross them out. You're left with sine theta, and we have a smiley face. Okay? So that's as easy as it is. You're able to use your salmon sheet for all of these proofs with the negative angles. and that's where you're going to kind of see those things. So here's the assignment that we're going to do in class, and I hope you all have a wonderful day.